Let's do the first question. It says a uniform semicircular lamina has a diameter of 0.8 meters. Find the distance of the center of mass of the lamina from AB. Okay, let's assume that the center of mass is at G, there, point G. So we have to find this distance that is given by OG is equal to R sine alpha upon alpha into 2 by 3. You should be knowing this formula. It's given in the MF9, where R is the radius, which is 0.8 divided by 2, 0.4. Sine alpha. Alpha here is the angle, this angle right here, 90 degrees. I'm going to write that as pi by 2 upon alpha is pi by 2 times 2 by 3. Let me adjust that, it's not fitting in the camera. Okay. Simplifying that, you should be getting OG as 8 upon 15 pi, which is the answer. Let's move to the second one. The question says, the lamina rests in a vertical plane with point B of the lamina in contact with a rough horizontal surface with A vertically above B. Equilibrium is maintained by a force of magnitude 6 Newton in the plane of lamina, applied to the lamina at A and acting at an angle of 20 degrees below the horizontal. Calculate the mass of the lamina. Let's assume the weight BW. Now, where's this one? Okay. Now the lamina is at rest on a horizontal surface, a rough horizontal surface, and a force is acting at 20 degrees below the horizontal at A, which means this is the horizontal at A, and some force, let's call that F, and it's acting at 20 degrees. And here we have the reaction force and the the frictional force. We have the frictional force acting, and we're supposed to find the mass of this lamina. In order to find that, we take moments about point B. It is actually easier to take moments about point B because the reaction force at B and the frictional force at B cancel out as we're taking from this point, and these forces pass through B, so they're easily cancelled out. And we know this distance is 8 upon 15 pi. Okay, let's take the moments. R cross F, R is this, cross F, that is this side turning into this side. We get the perpendicular distance is 8 by 15 pi. This side it is W into the perpendicular distance, 8 upon 15 pi. This is equal to the force at A. The force at A acting along the horizontal is F cos 20. We're taking it along this horizontal direction. There are actually two components for this force if you observe. There is one horizontal and a vertical component, which is F sine 20. But since that force is passing through the point B, that would be 0. So we're not going to write that. So let's consider this force acting in the horizontal. F cos 20 into this perpendicular distance, that is a diameter, that is 0.8. F is 6 newtons. It's given in the question. So simplifying this, we get mg into 8 upon 15 pi, that is equal to 6 cos 20 into 0.8. We just have to find m. Doing the algebra, you get m as 2.65 kgs. That is the answer. Always give your answers to 3 significant figures. End of question.